G'day. Been a bit busy at work lately, and so I've been bringing a few things back to my workshop here to do, as they haven't got the equipment to do it there. And one of the things I've been doing is cutting out discs for various purposes. But I thought actually there's a few ways of doing that people may not have thought of. So this video is about cutting out circles and probably cutting a few corners as well. I've started here with a bit of 3mm sheet. These are a couple of 55 diameter discs that I want for a project that I'm doing. Both of these are going to end up with holes through the middle, but for the sake of this I'm going to make one with a hole and one without, just to give you an idea as to how to go about it. The first thing I'm doing is just marking these out, and I've just used pencil and a compass, really low tech, centre pop in the middle there, just so that I can get an idea of where they're going to go. I'm now going to go over to the shears and just basically cut them out. And not only I'll start with the square bit, but then I'm going to chomp off the corners until I get something roughly circular. When we come to the bit where we're trimming them up accurately, that pencil mark, I'm going to ignore that, and it'll probably be gone by then anyway. What's going to guide me is the hole in the middle here, because I want that hole to be concentric with the outside, or in the case of the one without the hole, I want that to be round. I'm using the bench shears to trim my part to size. It's not so much to size, I guess, as just sort of trimming off the excess. One of the things in a lathe that really slow things down if you've got to try and get a square part to round, because you can only take a limited depth of cut, and so you've got a lot of material to remove. So if I can trim it off with the shears, that makes it just a little bit quicker in the lathe. I've now nibbled my blanks out of a piece of sheet. The one with the hole is pretty obvious. Bolt, washer, nut, all that sort of thing. And I'm going to double nut that in a moment just to make sure it stays in one place. Set that up and take it down to size. Now, the key thing though is the hole in the middle is not the finished size. That's just a convenient size bit down from. What I'm going to do is, once I've got the outside round, I'm going to put that back into the chuck and take that middle hole out to give me the right size. The solid piece, or the piece without the hole, I've welded a bit of bar stock on there, just 3 tacks, so I can get a 3-jaw chuck on there. Eventually that'll be welded all round because I want something like that in the middle. Other options are double-sided tape and super glue. Particularly with those two, you probably want a bit of sacrificial piece of material in your chuck, face that off, and then glue your glue or tape your blank on. What I would suggest you do is you make up something like that. That's just a wooden plug with a 60-degree taper, so it matches the live center. But with that you can apply some pressure, because what happens with these things is that if you're not careful, the tool forces are such that it sort of peels it off, and so that's one way of keeping it on there. Afterwards you have to clean up with the super glue method. A little bit of heat should help pop it off. With the double-sided tape you're just going to get in there and pry and clean up with acetone and all the rest of the stuff. I've just finished drilling a hole pattern using the PCD function on the DRO. Now that boss on the other part I've since drilled and tapped, and so they're both bolted together because I want the identical pattern on there. These outer ones need to be enlarged to 12mm. These inner ones will probably stay the same on one disc and be enlarged slightly on the other. Now, for those the reason I'm showing you this is for those of you who have to drill holes on PCDs. I've talked about a Zeus book before, but in the Zeus book there is actually a set of coordinates for drilling anywhere from 3 up to 12 holes, telling you what the coordinates would be. So if you ever have to drill a set of holes in a PCD, then a table like this can help you, because what you do is you can put in, you know what your diameters and things are, and so you put that in and it calculates out, so you can actually work out what the coordinates are, which means that if you've only got a very simple very simple DRO, or you haven't got one at all and just using your hand wheels, you can still do a PCD. This is what those two discs were for. It's just a spacer. It's got a quarter Whitworth thread to go into a tripod. It's got a mounting face for, well, yet to finish that. But yes, I just thought I'd try doing something a little bit different. A couple of bits of LED tube and some discs, and there we go. I'm taking a short piece of material off this stub, and this is a setup that I detail in my bandsaw tips video, but this is how I start when I've got a slightly thicker disc that's not coming out of sheet, it's coming out of a stub end of a bit of round bar stock. I'm just about to put a shim in here because the blade is getting down towards the clamp position, and so I'll put that in there so that once it goes past, it's not going to sort of try and pinch the blade, and that'll help cut through. But that's how I make thin discs from stubs of material. You saw me cut a disc off on the bandsaw. That one was a little bit too thin to use this method on, but here's another one which I'm preparing. I guess the trick here is find your best side. Now both of these sides, if I use a square on them, are out. There's a little bit of a gap there. There's a much bigger gap there. So it's really one of those things that what I normally do is find the flattest side. I'll put that in the jaws, face off this side, and then flip it over and face off the other side, and hopefully that gets me a parallel blank. This one's 18 thick. I need to take it down to about 17. What I normally do when doing this is I'll face one side, as I said, flip it over, face that, and then put the bore in, and that's simply so that the bore ends up 90 degrees to the two faces. I don't worry about the outside diameter because I'll put that on a mandrel and then take that down to size once that's on the mandrel. This is the setup I use for doing the ODs of these gear blanks, and for any disc for that matter, with an inch bore. I've got my inch mandrel on here, and I've dialed that in so that that's concentric with the axis of the lathe, and then I can put the gears on there, or the blanks on there, and finish those off to size. So any slight, out of roundness and all that sort of thing, that'll deal with that. That's just there as a spacer. The two spacers I have here don't quite get there. Another thing that I do on this is I've actually got on this one I've got a key, on another one I've got a roll pin which I can put up against the jaw. Now for us cutting a spur gear that doesn't matter quite so much, but if I was cutting a spiral gear, helical gear, I'm going to take this whole assembly over to the dividing head. Because that's got some side forces to it, that might actually try and kick this mandrel round. Okay, and similarly I've got a keyway on here which I can put a bit of key into to lock these in so I don't get them moving around. Shouldn't be a problem with a spur gear, but I've certainly had it happen with helical gears. This is the second blank that I want to prepare. I need to take about 1/8 of an inch off the diameter, so not terribly much. Now this is actually bigger than the swing of my lathe. I run into the cross slide. Okay, One of the tricks you can use to get around that sort of thing is if your normal tool doesn't, reach, and this one will just because it's slightly offset from the tool post, but I've got, I guess you'd call it a right-hand boring tool. Doesn't get used terribly often, but it's for situations like this where, if I've got a diameter to turn and it's going to clash with the cross slide, I'll use this. You can also, if you've got a right-hand turning tool, you can also mount that, but that'll only give you a little bit of stick out. Now, normally you try and keep your stick out as short as you can, but there are times when you can't. This is one of them. So just to bear in mind that yes, if you have a problem reaching, you could use something like that, or you could use a right-hand tool, and that might get you out of trouble. This is a third way of processing discs. In this particular case, I've got a disc with 4 holes in it. And so what I've done is I put some washers behind here to space it out from the faceplate. And this time I'm actually going to turn the outside down. It's actually stepped, it's got a hat shape to it, so I'm going to do the step. Then I can stick it into a self-centering chuck and face off the outside and so on. This is just a slice off a bar, and it just happened to be about the right size, although a bit big in diameter, so I thought, right, that'll do. So that's another way. If for some strange reason this was 3 holes or 5 holes or something, another possibility, get a bit of scrap, drill and tap, and then hold that bit of scrap into a chuck, and then turn this way. So there are a few ways of processing discs, so you can get them machined all over. I hope it's been informative. So see you for the next one.